Hello everyone. Through this video we are going to discuss the concepts of three-dimensional coordinate geometry, and I'm going to pick up some important questions from the exercises. So here in this case, three planes are considered to intersect at a point O such that these three planes are mutually perpendicular to each other. Actually, we are going to consider here three planes are considered to intersect at a point O such that these three planes are mutually perpendicular to each other. Now there will be a question, in what way these three planes intersect each other. Actually, these three planes intersect along the lines, the axis x dash ox, then y dash oy, and z dash oz. As a result of this intersection, ultimately we are going to get 8 octanes. 8 octanes are formed. Since this is a 3D figure, it is actually a bit difficult to show in plain paper. The figure means the three axes in three-dimensional plane are considered to be like this. All these three axes will be having their respective extensions in this way. Z dash, this is when extended, x-axis when extended, x dash, this is when extended up to this y dash. So ultimately, as a result of this, we shall be getting 8 octanes. As we get in case of two-dimensional geometry, there are 4 quadrants. When two axes intersect in 2D plane, we shall be getting 4 quadrants. In case of three-dimensional geometry, these are named as octanes. Now, how to consider the positive and negative senses of x, y, and z? So here is the list. The octanes are written in this way, and at the same time the sign for x, y, and z. So coordinates will be written vertically. Coordinates will be written like this. So for first octane, then second one, third one, then fourth one, fifth, sixth, seventh, this is the 8th one. So coordinates are x, y, and z. So in the first quadrant, x will be first octant, x will be positive, as we get in case of first quadrant in case of 2D. Similarly, in the second one, it is negative. In the third one, again negative. In the fourth one, positive. This will be repeated for the remaining 4 octanes also, like this: plus, minus, minus, plus. Similarly, for y, in the first octant, y is positive. In the second one also positive. In the third one negative. Fourth one negative. As we get in case of quadrants. And this there will be repetition, means like this. plus, plus, minus, minus. Similarly, for z-axis, there will be, for the first 4 octants, all z values will be positive, and for the remaining 4 octants, all z values will be negative. So this is the sign convention. Using this, how can we determine the position of a point? So we shall come to exercise 12.1 here. Exercise 12.1. Question number 3 I am picking up because it is having relation with this particular table. So what is the question given here? Name the octants in which the following points lie. So I am picking up the first point, that is 1, 2, 3. Here will be 3 parts in a coordinate, means for the points of a for the 4 points in terms of coordinates. So in which octant will it be lying? We can find that the x coordinate is positive, y coordinate is also positive, z coordinate is also positive. It can be seen that in the first octant, in case of first octant, all these 3 coordinates are positive. So very clearly this is lying in the first octant. After that, I am picking up the next point, that is 4, minus 2, 3. It can be observed that the first one is positive, second, y coordinate is negative, then z coordinate is again positive. So in which octant can it lie? So very clearly it is lying in the 4th octant. This is the octant where only the y coordinate is negative. Therefore, it is lying in the 4th octant. Similarly, the next one I am picking up. Next one is 4 minus 2 minus 5. It is lying in which octant? It can be seen that it is lying in the 8th octant, because here in this case the first term is positive and the remaining 2 are negative. So the answer is the 8th octant. 8th octant. So this is the answer. This is how the remaining points can be determined. The positions can be determined. Now in question number 1 of this exercise, what is said? Question number 1. In question number 1, what is given? A point is lying on the x-axis. What are its y coordinate and z coordinate? So if we observe it in Cartesian coordinate plane, what can be noticed? This is the figure. If we observe here, this is x, this is y, this is z. So if any point, suppose any point is lying on this axis, very clearly its y coordinate will be 0 and z coordinate will also be 0. So the answer will be the y coordinate and the z coordinate both are 0. So this is the answer for first one. Next we shall come to the next topic, distance between 2 points. Distance between 2 points. So here in this case, suppose we consider 2 points. Let there be 2 points, capital P, x1, y1, z1, and capital Q, x2, y2, z2 in the 3D plane. In the 3D plane. Then distance between these 2 points can be evaluated. Then the distance between P and Q can be taken as PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. We can see that this is just an extension of the distance formula for two-dimensional coordinate system. So just the extended part is this part. Here we have to consider the z coordinates also. So we shall come to exercise 12.2 now. Exercise 12.2. 12.2. First question is what? Find the distance between the following points. Find the distance between the following points. I'm picking up the third one. All the four are of question number 1 are of the same kind. Therefore, only one I'm picking up. -1, 3, -4. This is the first point. And the other one is 1, -3, 4. So, here in this case, the required distance is equal to square root of course this formula we are going to use here. So 1 minus -1 whole square plus -3 whole square, then after 4 minus -4 whole square. So what would I get? 1 plus 1, that means 2 square plus -6 whole square plus 8 square. So ultimately the result will come as 4 plus 36 plus 64. This will be equal to root 104, which will give us the result of 2 root 26, and this is the answer. After that we shall come to question number 2. In question number 2, what is given? Show that the points -2, 3, 5 comma, after that 1, 2, 3 and 7, 0, -1 are collinear. Now the concept of collinearity implies here what? If the 3 points are considered to be A, B and C, then by using distance formula we shall be finding out what is the value of AB, then BC, then CA. After that we need to find that sum of any two sides out of these 3 should be equal to the remaining side. That means we should get something like AB plus BC equals to CA, or BC plus CA is equal to AB, or AB plus CA is equal to BC. Any one of these 3 if we get, then it will imply that these 3 points are collinear. So what we shall do, first of all, in the solution part we shall write that let the points be taken as capital P -2, 3, 5, then after capital Q, that is 1, 2, 3, and capital R 7, 0, -1. After that, using distance formula, we are going to evaluate the respective values of PQ, QR and RP. Then PQ will be equal to square root of, I'm going to use a distance formula, 1 minus minus 2 whole square plus 2 minus 3 whole square plus 3 minus 5 whole square. That will be resulting into ultimately 9 plus 1 plus 4. That is equal to root 14. Similarly, we shall come to QR. That will give us the result what? 7 minus 1 whole square plus 0 minus 2 whole square plus minus 1 minus 3 whole square. After that, the result will come like this. It is 36 plus 4 plus 16, and that will give us the result of root 56, and that will be 2 root 14. So this is the answer for QR. And then the last part is left, that is PR. So for PR, what we shall be getting from the coordinates using distance formula, 7 plus 2 whole square plus 0 minus 3 whole square plus minus 1 minus 5 whole square. That is equal to, we shall be getting the result as 81 plus 9 plus 36, which will give us the result of 126 under root sign, and that will be equal to 3 root 14. So very clearly from the values of PQ, then QR, then PR, we shall get what? Clearly PQ plus QR is equal to PR. This will imply that points PQR are collinear. PQR are collinear. And that is the answer. Then coming to question number 3, verify the following. From these I am picking up the first one. We are to show what? 0, 7, minus 10, then after 1, 6, minus 6, and 4, 9, minus 6 are the vertices of an isosceles triangle. Isosceles triangle means triangle having two equal sides. So first of all, we have to assume these 3 points to be A, B, C respectively, or PQR. We shall be writing, let the given points be taken as capital P, 0, 7, minus 10, then after capital Q, 1, 6, minus 6, and capital R, 4, 9, minus 6. Now let us find out what is PQ using distance formula. So when we put the values, what we shall get? 1 minus 0 whole square plus 6 minus 7 whole square plus it is minus 6 plus 10 whole square. On simplification, we shall be getting the results to be 1 plus 16. The result will come as root 18. Now let us come to QR. Let us see. what result we may get here. So here in this case, using the coordinates of Q and R by distance formula, we shall be getting 4 minus 1 whole square plus 9 minus 6 whole square plus minus 6 plus 6 whole square. So the results will come as 9 plus 9 equals to root 18. So very clearly these two sides are equal. So this will imply that PQR is an isosceles triangle. Since PQ is equal to QR, this implies triangle PQR is isosceles. So this is the answer. Next we shall come to question number 4. So in question number 4, what is given? Find the equation of the set of points which are equidistant from the points 1, 2, 3 and then we get 3, 2, minus 1. So in the solution part, actually we are going to consider these two points as point A and point B, and the set of points which are equidistant, that means lying at equal distances from A and B, we are going to consider that point as capital P. So next, let the set of points equidistant from, say, capital A 1, 2, 3 and capital B 3, 2, minus 1 B capital P x, y, z. So according to question, what do we get? PA is equal to PB. Of course we have to go for distance formula now. So this will imply, using distance formula, x minus 1 whole square plus y minus 2 whole square plus z minus 3 whole square. On the other side we shall be getting x minus 3 whole square plus y minus 2 whole square plus z plus 1 whole square. So squaring both the sides, we have to remove the square root sign actually. So squaring both the sides, we shall be using the formula for a minus b whole square and a plus b whole square wherever necessary. So when we square both the sides, the root signs will be getting removed. So let us square both the sides. Square root signs will be getting removed, and then splitting, we shall get x square minus 2x plus 1 plus y square minus 4y plus 4 plus z square minus 6z plus 9 is equal to x square minus 6x plus 9 plus y square minus 4y plus 4 plus z square plus 2z plus 1. Then let's go on cancelling like this. Then after similar terms, 4 can get cancelled, 9 will be cancelled, 1 will be cancelled, and what is left? Minus 4y will get cancelled. Among the terms which are left behind, we can shift 6x minus 6x to the opposite side, and then minus 6z with that minus 2z equals to 0. So we shall be getting 4x minus 8z equals to 0. Dividing both the sides by 4, x minus 2z is equal to 0. So this is the required equation. After that, we shall come to the last question of this exercise. What is there? Find the equation. Find the equation of the set of points capital P, the sum of whose distances from capital A 4, 0, 0 and capital B minus 4, 0, 0 is equal to 10. So the set of points, let the set of points capital P be x comma y comma z, because that is not known to us. According to question, what are given? PA plus PB equals to 10. It is already given in the question. So of course we have to take help of distance formula for constructing PA and PB. So using distance formula, we shall be writing, sorry, here it will be minus, of course. This is minus 4 whole square plus y minus 0 whole square plus z minus 0 whole square. Then after again square root x minus 4 whole square plus y minus 0 whole square plus z minus 0 whole square, that will be equal to 10. Then after what we shall get? Root x minus 4 whole square plus y square plus z square. Then this term will be shifted to the opposite side. So here in this case 10 minus root x plus 4 whole square plus y square plus z square. Let us now square both the sides. So squaring both the sides, what we shall get? The calculation seems to be actually big. Whole square plus y square plus z square, that is equal to, means square root sign on LHS got removed. On the other side we have to use the formula a minus b whole square. So what do we get? Using that formula we shall be getting x plus 4 whole square plus y square plus z square plus this term will be getting squared. So x plus 4 whole square plus y square plus z square. So very clearly these two terms will get cancelled. After that what will happen? Let us see. Let us split it up. X square minus 8x plus 16 is equal to 100 minus 20 root x plus 4 whole square plus y square plus z square. After that again x square plus 8x plus 16. So these two terms got cancelled, these two again got cancelled. What do we get next? It will be arranged like this: x plus 4 whole square plus y square plus z square. I prefer to keep it alone in one side so that on squaring the square root sign will be getting removed directly. So it is 100 plus ultimately 16x. 100 plus, will it be 100 plus 16x? Yes, it is 100 plus 16x. On both sides by 4 on both sides division can be performed. So it is 5 root x plus 4 whole square plus y square plus z square. Then here it is 25 plus 4x. Now let us square it. Square both the sides. Then what result we shall be getting? 25 within bracket x square plus 8x plus 16 plus y square plus z square equals to 100 plus 200x plus 16x square. Now let's break it. 25x square plus it will be 200x plus 400 plus 25y square 25z square is equal to 100 plus 200. I'm making mistake. Actually it should be 25 square is 625. It is 625. Here also it will be 625. So let us make it correct. 625. Here also it is 625. 200x then 16x square. So 200x on both sides got cancelled. Then 16x square on shifting to left hand side 9x square we shall get, followed by 25y square we have to arrange here, then 25z square, then after plus 400 minus 625 equals to 0. So what result we shall get? We shall be getting 9x square plus 25y square plus 25z square minus 225 equals to 0, and this is the required equation. So with this exercise gets over. Thank you.